Mars has a volcano so tall that if you stood on top of it, you'd be above 99% of the planet's atmosphere. You'd essentially be standing in space on a mountain, Olympus Mons, 16 miles high, 2.5 times the height of Everest. Its base is the size of Arizona. The whole country of France could fit inside the footprint of a single volcano. And here's the part that quietly breaks your brain. The slopes are so gradual, about 5 degrees, that if you were standing on one, you wouldn't know you were on a mountain. You'd think you were on a flat plain. The curvature of Mars would hide the summit from you. You'd be climbing something the size of a small continent, and your legs would never suspect a thing. This is Mars, the planet that looks small and simple from a distance, but is hiding the biggest, deepest, and most deceptive geography in the solar system. Also, the planet that everyone wants to move to, despite the fact that the air would boil your blood in about 15 seconds. Let's talk about that. Mars is cold, much colder than most people imagine when they picture the plucky red frontier. Average surface temperature, minus 80 degrees Fahrenheit. That's the average. On a warm summer day near the equator, it can reach a balmy 70 degrees Fahrenheit. T-shirt weather, almost. But at the poles in winter, it plummets to minus 225 degrees Fahrenheit. That's cold enough to freeze carbon dioxide out of the atmosphere. It literally snows dry ice on Mars. Tiny frozen CO2 particles drifting down from the sky like the universe's most depressing Christmas. The reason is distance and atmosphere. Mars sits about 142 million miles from the sun, 50% farther than Earth, and its atmosphere is almost non-existent by Earth standards. The surface pressure on Mars is about 0.6% of Earth's, less than 1%. If you stepped outside without a suit, two things would happen almost simultaneously. You'd suffocate. The atmosphere is 95% CO2 and contains essentially zero breathable oxygen. And any exposed liquid in your body, saliva, moisture in your lungs, tears, would begin to boil. Not because of heat, because the pressure is so low that water's boiling point drops below your body temperature. You wouldn't freeze first. You wouldn't choke first. Your blood would fizz. Max steps out onto the surface, full suit, full helmet. He can feel the cold even through the insulation. Not painfully, just persistently. A constant, dry, deep cold that sinks into materials rather than hitting you on the surface. Cosmo is in his suit next to him. Cosmo's breath fogs the inside of his bubble helmet immediately. Within 30 seconds, Cosmo can't see anything. He sits down. If you can't see, you sit. That's Cosmo's protocol. Max wipes Cosmo's visor for him. We're going to have to fix this. They are not going to fix this. This will happen on every planet. The sky on Mars is the wrong color, and it messes with you more than you'd expect. During the day, the Martian sky is a butterscotch pink, not blue. Fine suspended dust particles in the atmosphere scatter light differently than Earth's nitrogen and oxygen molecules do. On Earth, shorter wavelengths, blue, scatter more, giving us a blue sky. On Mars, the iron-rich dust scatters longer wavelengths, turning everything a hazy salmon. But here's the genuinely weird part. Sunsets on Mars are blue. When the sun dips toward the horizon, its light travels through more atmosphere and more dust. The fine particles in the Martian atmosphere scatter the red and yellow light away. And what's left, the blue wavelengths, make it through to your eyes, so you get a cold, pale blue sunset on a planet that's famous for being red. It's backward. Earth has blue skies and warm sunsets. Mars has pink skies and blue sunsets. Every instinct your brain has about what outside should look like is inverted. Max stands watching the sun go down. It's smaller from here, about 2/3 the size it appears from Earth. The blue halo around it is eerie, not beautiful in the way an Earth's sunset is beautiful. Beautiful in the way something slightly wrong is beautiful, like a chord that resolves one note off. Cosmo doesn't look at the sunset. Cosmo is sniffing a rock. The rock is iron oxide, rust basically. The entire planet is covered in rust, which is why it looks red from space. Mars is a rusty desert the size of all Earth's dry land combined, and Cosmo has found the one rock he wants to investigate. Valles Marineris. If you think the Grand Canyon is impressive, stop, recalibrate, then multiply by 10. Valles Marineris is 2,500 miles long. It would stretch from New York to Los Angeles. It's 375 miles wide at its widest point and over 6 miles deep. The Grand Canyon is 277 miles long, 18 miles wide, and about 1 mile deep. Valles Marineris could swallow the Grand Canyon and lose it in a side channel. And unlike the Grand Canyon, which was carved primarily by the Colorado River over millions of years, Valles Marineris was ripped open by tectonic forces. The Tharsis volcanic bulge, the massive region where Olympus Mons sits, pushed up the crust so violently that the planet's surface cracked like a windshield. Then erosion, landslides, possible ancient water, and billions of years of collapse widened and deepened the wound. Mars has a scar that runs a quarter of the way around the planet, and it's still there, unhealed, because Mars doesn't have the plate tectonics or liquid water to erase it. On Earth, erosion and tectonic recycling would have filled it in or pulled it apart by now. Mars just keeps it, like a planet that never got over what happened. Max flies the ship along the canyon at low altitude. The walls extend up and out of sight on both sides. Sheer cliffs higher than any mountain range on Earth, dropping into darkness below. It goes on for hours. They fly, and the canyon doesn't end. This doesn't make sense, Max says. It's still going. It keeps going. 2,500 miles of it. The ship's fuel will run out before the canyon does. Cosmo has fallen asleep in the co-pilot seat. He slept through the largest geological feature in the solar system. He is consistent. Mars had water. A lot of water. This isn't speculation anymore. It's confirmed. Mars has ancient river valley networks carved into its surface. Branching channels that look exactly like river systems on Earth when viewed from above. It has deltas, lake beds, mineral deposits that can only form in the presence of liquid water. And the Curiosity rover has been driving through Gale Crater, what was once a lake, for years, analyzing sedimentary rock layers that formed at the bottom of a body of standing water. 3.5 billion years ago, Mars had rivers, lakes, and possibly an ocean covering much of its northern hemisphere. The atmosphere was thicker, the temperature was warmer, the surface was wet. Then Mars lost it, all of it. What happened is almost tragic if you think about it too hard. Mars is small, about half Earth's diameter, with only 38% of Earth's gravity. Its core cooled faster than Earth's. When the core solidified, the planet lost its global magnetic field. Without a magnetic field, the solar wind, a stream of charged particles from the sun, began stripping away the atmosphere, molecule by molecule. Over hundreds of millions of years, Mars went from a thick, warm atmosphere to the thin, frozen wisp it has today. With the atmosphere gone, the pressure dropped. Water couldn't remain liquid on the surface anymore. It either froze underground or evaporated and was carried away by the solar wind into space. Mars literally lost its water to the void. Earth and Mars started with similar ingredients. Earth kept its magnetic field. Mars didn't. That's the difference between oceans and dust, between life and silence. One spinning iron core away from a completely different outcome. Max crouches down and picks up a handful of Martian soil. It's fine, rusty, bone dry. But somewhere under his feet, maybe a few yards down, maybe a few miles, there's ice. Lots of it. Subsurface water ice, confirmed by radar, stretched across the polar regions and even at some mid-latitudes. Mars didn't lose all its water. It buried some. There's ice under here, Cosmo. Cosmo starts digging. Against all probability, this is the one time Cosmo's instinct to dig at everything is scientifically appropriate. He doesn't find ice. He finds more rust. But the effort is noted. Mars has dust storms that can swallow the entire planet. Not hyperbole. Literal, planet-wide dust storms. They typically start small, localized wind events near the equator. But Mars's thin atmosphere and extreme temperature differences between sunlit and shaded areas create powerful convection. Once a storm gets going, it picks up fine dust that further heats the atmosphere, which creates more wind, which picks up more dust. A feedback loop that can expand a regional storm into a globe-encircling catastrophe within weeks. The 2018 global dust storm is what ended NASA's Opportunity rover. After 15 years of operation, way beyond its planned 90-day mission, Opportunity got caught in a storm so thick that sunlight couldn't reach its solar panels. It went into hibernation. It never woke up. Opportunity's last transmission, translated from engineering data, was effectively, "My battery is low and it's getting dark." NASA tried to contact it for months. Nothing. They declared it officially gone in February 2019. A robot that survived 15 years on Mars was beaten by dust. Max watches a dust cloud forming on the horizon. It's far away, but growing. The Martian sky, already pink, turns a darker ochre. Visibility drops. Fine particles start hitting the ship's hull, a gentle hissing sound like sand on a tent. We should probably go. Cosmo is standing at the window, ears forward, watching the wall of dust approach. His tail isn't wagging. It's not fear, it's focus. Cosmo has two modes when facing an incoming threat: complete obliviousness or laser focus. This is laser focus. This is the 20%. Max fires the engines. They climb out of the dust and into the black sky above. Below them, Mars disappears under a blanket of its own debris. The gravity on Mars is 38% of Earth's. If you weigh 180 pounds on Earth, you'd weigh about 68 pounds on Mars. You could jump roughly 2.5 times as high. Carrying heavy equipment would feel manageable. Walking would have a strange, bouncy quality. Every step a little too long, every motion a little too floaty. It sounds fun until you think about the long-term consequences. Human bones lose density without adequate gravitational stress. Muscles atrophy. Cardiovascular systems weaken. Astronauts on the International Space Station in zero gravity exercise 2 hours a day and still come back to Earth measurably weaker. Mars gravity at 38% would slow the deterioration, but not stop it. If humans lived on Mars for years, they might never be able to return to Earth. Their bodies would adapt to the lower gravity and be unable to readjust to Earth's 2.6 times stronger pull. Their children, if born on Mars, would grow up with lighter bones and less muscle mass. A generation raised on Mars would be Martians in a very real physiological sense. Humans who physically cannot come home. Mars doesn't just take your water and your atmosphere. Given enough time, it takes your ability to leave. Here's what nobody in the "let's colonize Mars" conversation likes to talk about for very long. Mars is actively trying to end you in ways that don't photograph well. The radiation is relentless. Without a global magnetic field or a thick atmosphere, Mars's surface gets hit with cosmic rays and solar radiation at levels that would significantly increase cancer risk over a multi-year stay. NASA estimates that a round trip to Mars, just the travel, not counting time on the surface, would expose an astronaut to roughly 2/3 of their entire career radiation limit. The soil is toxic. Martian regolith contains perchlorate salts, chemical compounds that, on Earth, are industrial contaminants. They interfere with thyroid function. They're corrosive, and they're everywhere on Mars, mixed into the dust that covers every surface and gets into everything. The isolation is extreme. At its closest, Mars is 34 million miles from Earth. At its farthest, 250 million miles. Communication delay between 4 and 24 minutes each way. No real-time conversation conversations, no emergency rescue. If something goes wrong on Mars, you're on your own for at minimum several months until a launch window opens, and then it's another 7 to 9 months of travel. Mars isn't hostile the way Venus is hostile. There's no crushing pressure, no 867 degrees Fahrenheit surface, no sulfuric acid rain. Mars is hostile the way a desert is hostile. Quietly, patiently. It doesn't attack. It just waits for you to run out of something. And yet, Mars has everything we need to stay. Not comfortably, not easily, but theoretically. Water ice underground. CO2 in the atmosphere that could be converted to oxygen. Soil that, once cleaned of perchlorides, contains the mineral nutrients plants need. Solar energy, reduced but usable. And the raw ingredients for making rocket fuel from Martian resources, a process called in situ resource utilization that NASA has already tested with the MOXIE experiment aboard the Perseverance rover. Mars is the one place in the solar system besides Earth where humans could realistically build something permanent. Not because it's welcoming, it's not. Because it's just barely possible. And barely possible is exactly the kind of challenge that humans are designed to throw themselves at. Mars used to have rivers. It used to have an atmosphere. It used to be warm. All of that is gone now, stripped away over billions of years by the loss of a magnetic field and the relentless patience of solar wind. But the ice is still there. The raw materials are still there. The bones of a habitable world are buried under the rust. Max stands on a ridge overlooking a dried riverbed. You can see it clearly. The way the channel curves, the way the banks erode inward, the way tributary channels feed into the main flow. This was water, real water, moving across real rock. Maybe 3 billion years ago, give or take. He looks down at Cosmo, who is sitting next to him, looking out at the same dry channel. Cosmo doesn't know it used to be a river, but something about the shape of it holds his attention. Dogs understand water. Something in his brain registers the pattern, even without the substance. This whole planet is a ghost story, buddy. Everything that made it alive is gone, but the shapes are still here. Cosmo's tail wags once, slowly. Mars doesn't ask you to love it. It asks you to remember what it used to be and to imagine what it could become again. And honestly, that might be enough. Next time, Max and Cosmo are heading to the biggest planet in the solar system, a gas giant with no surface to stand on, a storm that's been raging for 350 years, and a moon that might have more liquid water than Earth. Jupiter doesn't mess around.